All right, let's. I spent a huge amount of time making sure that the QR code was the right size and failed to actually test to make sure it was that it worked. Oh my God. It took like 2 hours to get the thing to pop up right in the slides. I hate slide technology sometimes. All right. Right, so the goal today is actually to talk about peer review, since you're now at that point where that's going to become the expectation. And how many of you have done peer reviews before? How many of you have written something like, oh, it looks great, as a peer review? Right, so in other words, it was basically performative theater. Now, how many of you have actually done anything in industry, co-op, that kind of thing? Have to ever do a PR? Like actually, what is a PR?
It's basically like you submit something on a forum. If your code is good, then it gets merged in. If it's not, it gets reviewed or rejected.
So did you review somebody else's code, or did you just get reviewed?
Both.
Okay. That's a peer review. You're being reviewed by people who are your peers, and they're taken very seriously, because literally, if people just say, good job, and then the change goes into production, and then the next day, the vice president of engineering is there going, you signed off on this peer review, and there was a bug in it that you really should have caught, and it cost us $500,000. How are you going to feel? I mean, I'm not making this stuff up. I mean, I'm not saying every error you make is going to cost $500,000, but the reason that we have peer review is because the person who wrote the code doesn't see what the code does, they see what the code is supposed to do. When you sit down and write a piece of code and you look at your own code and say, what's wrong with this code? You're not seeing what you wrote, you're seeing what you think you wrote. And you swear at it because it's not doing what you told it to do. But odds are it is. If I had a nickel for every time somebody blamed the compiler for a bug, I'd be able to buy a coffee from Starbucks. How many actual compiler bugs have you ever actually seen? How many CPU bugs? I have actually been able to clearly identify one processor bug in my entire career. It took me 6 months to nail the thing down. And the actual fix was to change a loader flag. Oh, just don't generate the code that causes that bug to happen. Those are rare. So the reason you do code reviews is because someone else who looks at that code is going to say, I'm not seeing what you think you wrote, I'm seeing what you wrote. And I'm going to give you some feedback on it. The same thing applies to design, except that the impact for design reviews is much higher than the impact for code reviews. Why? Where is the most expensive place to fix a bug?
Prod.
Sorry?
Where's the most expensive place to fix a bug? After it's already in prod?
Right. Yeah, in the field. One of those fun things to do is to actually go to some facility someplace, usually in Timbuktu, where the last little bit was riding a burro into the data center there. And they're very grateful when you get there because you've come to fix their problem that can only be reproduced in their facility. And you get there, and of course, they're very appreciative. Thank you. And then the first question, it's always the first question, how long is it going to take to fix this? And I can tell you after years of doing this kind of thing, the answer is, probably about 5 minutes. The challenge right now isn't fixing it. The challenge is in figuring out what I need to fix. I don't know how long that's going to take. And then they'll stand there and look at you over their shoulder as you start doing things. And you better impress them, right? You're going to have to look like Mr. Robot, or otherwise they're not going to be impressed with you. If you're not using a command line terminal and typing things they don't understand, they're going to be like, who is this person? They don't know anything. Seriously, though, what's actually going to happen is you're going to fix what are the most expensive kinds of bugs, which are those that only occur in production, out in the field. And they really do happen. And the best place to fix it is actually in the design. Why? Because you haven't written any code yet. Design bugs are in fact some of the most impactful. Why? Because if you make a bad design decision, somebody's going to be building the wrong infrastructure in the first place. So identifying that this is the wrong infrastructure now, rather than when it's shipped to a customer or in beta test or even in development testing, you have the most impact. That's one of the reasons designs are so incredibly important. You're making broad decisions about the architecture of the product itself, of what you're building. Now, you're not building big, complex projects here yet, but at some point in your career, you will. Well, I hope so. If not, maybe you'll just be working at Starbucks. Hey, they need IT people too. Good feedback identifies something concrete, something that's actionable, something that you can actually fix. I realize I need to make sure that the audio is working because I've made that mistake once before. It's like different things turn off. You're like, what? Why is it off this time? What can you do? Or if something's not clear to you, ask a question. If something is clear to you, but you're asking a question of a senior person and you don't want to offend them, ask a question. Don't tell them they're wrong. Ask them a question that makes them look at the problem differently and say, yeah, there's an issue here. That's how you ask questions up, so you don't piss people off. Make sure they're grounded. Now, generally you want to avoid taste-driven feedback. Well, I didn't really like the color of the font that you used. What? I don't like that font phase. I mean, maybe if you're doing website reviews, that'll work fine, because I've seen pretty bad websites. But most of the code you're going to be looking at is probably going to be stuff that no one actually really looks at, no one actually sees because it's operating inside of some larger chunk, some larger piece. But you don't want me writing your GUI code, I'll tell you that much, because I would pick the wrong color palettes and I would use fonts that were really difficult to see, and I, of course, would make sure that everything was white on white. Do you know why you put white on white text on a web page? Why? Yeah, that's exactly why. So there's this whole trick with CVs, resumes, is that you put white on white text inside of the PDF so that the LLMs will see it. Literally, people will like embed, hire me. Oh, like that's going to work. It turns out it does. Or better yet, I'll give you $50 if you make sure I get an interview. White on white. No human's going to see that. He's laughing. He's like, this is great. I'm going to make sure I do this. Yeah. If you go do some searches pretty fast, you'll find people actually are doing that. So look at what did they choose for technologies. Why did they choose VMs versus container versus serverless? What trade-offs were they considering? Or did they just simply roll the magic, pull the magic 8-ball out and go, oh, my 8-ball, what should I be doing? You got a magic 8-ball, right? You've seen those stupid things. They're kind of dumb, but they're very useful for making important technical decisions. Like, should I do this? It's cloudy. Try again. Great. Okay. What kind of database? Did they use a relational database? Did they use a NoSQL database? Did they use a vector database? And of course, now the safe answer is, oh, well, I used Postgres. Why? What was the motivation? What did you need it for? I mean, this morning, because I have nothing better to do in the morning but watch YouTube videos. I was watching a YouTube video that was talking about using Postgres with some other full-text search engine rather than using Elasticsearch. Now, does that mean anything to you? Or did I just simply look at you and speak to you in, I don't know, Quechua? Which is a real language, by the way. What is Elasticsearch? He knows, he doesn't want to say. Okay, that's fine. He's going to be cool about it. Why would you use Elasticsearch? Make a guess. My gosh, if I ask ChatGPT, it'll make a guess. It'll fabricate something even if it doesn't know. You guys are just not willing to say anything at all. That's great. Elasticsearch is, in fact, a mechanism, and I'm not going to do this very often, is actually a mechanism for searching free text data. So people put their data into Postgres, but they index it with Elasticsearch because, frankly, Postgres search facility, their free-form text search, sucks. It's really bad. It basically just becomes a simple textual search engine. And you don't want to use that if you're like building a searchable database. So what kind of database did you use? Why did you use it? What was the purpose? What was the function? What was the problem it was solving? Managed versus self-hosted. You know, are you running things? Are you using some automated system? Are you using a single cloud provider? Multi-cloud is all the rage now, right? In fact, I was just reading that Amazon is now actually doing multi-cloud management. After for years, literally years, telling people not to do that, Amazon is now on the bandwagon and you can connect your GCP or Azure instances into your Amazon virtual private cloud. We give up, fine. Whatever you want, we'll do it. They're still going to charge you for the egress. What's an egress charge? That one you're going to have to look up, because that one you're going to need to know. I'll give you a hint. It's kind of like charging you to use the road in one direction. If somebody says, we use lambdas because it's popular, because we asked the magic 8 ball, you might want to question them. You might want to put that into your peer review. I don't think that was a legitimate technical decision. When you're looking at their IAM design, did they go through a least privilege check? Because we just did the IAM stuff. Did they do a least privilege check? Did they separate out the roles? Do you know what this particular piece of the system has to be able to do? Is that all it can do and no more? How are secrets handled? Oh, I don't know. I just put them in a file and check them into GitHub, right? Do you know that it's so bad that GitHub now actually has automated scanners that will tell you when you're being a bonehead and have checked in your API keys into your Git repository? You know why? Because there's other people who are scanning GitHub as fast as they can to grab those keys and use them before you get a chance to invalidate them. There's whole secret management systems. Some of them are simple, some of them are complicated. You have to pick one. When you're doing a code review, you get to be on the other side of this and say, why did you choose a plain text file in your root directory of your repo to store all of your secrets? But thank you very much for the API keys. I have managed to use them and run them all night long. So enjoy the bill. Service identities. Do the services have scoped permissions? In other words, did I make sure that I did least privilege, that I knew what the role was, and that I was managing these correctly relative to what I was trying to do? If they're giving admin access to everything, for everything, keep track of their project so that when it actually ever gets deployed on the actual internet, you'll be able to really steal their API keys and use them. Not that I'm condoning that kind of conduct, but it will happen. What if they're doing a CI/CD? Is there an automated build, test, deploy pipeline? If there isn't one, that's a great thing to say. I didn't see your CI/CD pipeline here. How are you going to test this thing? How are you going to know before you just ship your crappy code to the field into production that it actually works? If a test actually fails, does it block deployment, or do you just simply put a red button on a console someplace that nobody pays attention to? Because I can tell you, tests that don't break the deployment get ignored. Just like imagine you had an assignment for a class where all you had to do to get credit for it was just simply push a button. Submit one word. Hi, done. Okay, I got all the credit for that. What's the temptation? You're just going to do it, right? Because, it obviously is important. Call them on it and say, your testing isn't blocking your deployment. Where's the rollback plan? What are you going to do when something goes wrong? And something always goes wrong. Everything will break in the cloud. I mean, if you're sitting there in 4.16, at least a few people, in 4.16, that's all I spend my entire time talking about is all the things that can go wrong. And most of them you don't have to see because you're in 4.36 and they've already been bundled behind API gateways that will protect you against most of those failures, but nothing can protect you against all of the failures. Things will break. Someone will misconfigure a DNS server someplace and then everything comes crashing down around. You're going to screw things up. So what is the rollback plan? How are you going to recover from that? How do you separate development, staging, and production? Are they distinct? And are you convinced that they are similar enough that a failure in production should have been identified in testing or staging? See, this is one of the dangers, is that, it worked fine in dev test. It worked great in staging, and then we put it to production, and it fell over dead because there was an assumption that we made that didn't work in production. And that's when you then find out that your rollback plan didn't work either. Did these sound real? Have you ever screwed any of this kind of stuff up? Oh, there you go. Okay, he has. And if he said no, I was going to say you will. Because he will. It happens. It is part of the process. Since we've been talking about CCTs, okay? So they claim something in their project. How do you verify this? Literally call them on it and say, wait a minute, excuse me, you claimed that you're not storing any PII. How do you know? You said you're not sending any PII outside of Canada, but all I see is a check to see if the name is correct. How do you know that name for that service is still in Canada? Is there an enforcement mechanism for these controls? For anything, any test has to have some sort of an enforcement point. And make sure the tests exist. If somebody says, we would test this, it's like, great, okay, well, the road to hell is paved with these kinds of things, right? Don't promise something if you're not delivering it, and call people on it when they do that, and you're doing a review. You're doing a peer review. You are there to try and keep them honest. And they're going to return that favor. They're going to try and keep you honest as well. I've mentioned this before. Sometimes you have tests that require human or external validation. We comply with SOC 2. What's SOC 2? I don't know. Go look it up. It probably won't be applicable to your project, but there will be at least one project in this class probably where it is. It's all about data handling. It's all about the sensitivity of the data. It's about regulatory compliance. Data is encrypted at rest. Well, where's your key management system configuration? How do I know it's actually being encrypted at rest? Show me the pipeline. If I see a client claim like that and I can't find the code to match it, I'm going to ask them a question. I'm going to say, I saw you claimed the data is encrypted at rest. Where do you validate that? Because I don't see your KMS configuration. What's a KMS? Look it up. You can actually have someone verify that things have been audited for compliance and put it in some sort of some sort of time-stamped attestation. Then when the time has gone past the window, you have a red test that starts failing the deploys. It's no longer allowed to be deployed because nobody's bothered to go look and see that this condition is still true. Does that mean that the condition could expire somewhere in the middle? Yes. But it also means that eventually you're going to notice it because nobody's taking care of that. Oh, that was Samantha, and Samantha left 6 months ago, and nobody else is handling that anymore. It happens in organizations all the time. People leave. The things they were responsible for that are only periodic they roll underneath the table. Nobody notices them until there's a test to actually validate it. So, how many of you actually looked at any of the sample projects? They're on Canvas. I put them there. So, I saw one head nod, so at least somebody noticed they were there, but nobody looked at them. Okay, fair enough. The idea was to look at them and to tell me which ones you liked and which ones you didn't like. Now, they're not actual student. These were synthesized because I didn't want to use student capstone reports. I have to go and ask people, and then maybe in the future I will. But most of the people who did bad ones, they aren't going to want you to use theirs. Yeah.
How long should it be on average? Because there were like 2 pages at most, or 3 pages.
How long did you expect it to be?
I mean,
If you can't explain to me what it is in 2 or 3 pages, then how long should it be?
I thought there would be like, for instance, the cost control test. Like they only had like 1 or 2 examples on there, but I guess maybe it's just like a sample.
Right.
So the real ones would be a lot longer because we have all this.
I wouldn't put the CCT test in my report. I'd refer to my CCT tests in my report, perhaps, or I might even put a table in that says, here are the things I tested, and you can put like 3 columns wide. I mean, the goal isn't to go for length. I'm not going to staple them all together. This is the old way of grading, right, where you send your report in, and then I stand at the top of a set of stairs, and I throw the reports, and those that land the closest, because they're heavy, are the ones that get the best grade. So you just start grading here. Oh, this is a 96. This is a 94. That's a 92. That one's an 88. Oh, look, there's a 39 down there. That's the one that sails all the way to the bottom. I'm not going to grade that way. You might feel like I did, but I'm not going to. So it sounds like you at least looked at them. I mean, the other goal was not to make this thing some huge onerous kind of task. It was instead to give you a sample. So let's see, since we have less time than usual here, pick one report, go through it, spend 5 minutes on it, and then tell me at the end, is this good? Is this not good? I mean, don't look at the next slide because it will tell you the instructions, the rating for it. While you're going through it, do I trust this team's claims? What evidence do they provide and what's missing? Now, of course, the whole idea was to have you look through all 4 and to say, which of these do I want to be associated with my name? I mean, in general, the reports were pretty small. They were under, I don't remember if anybody went over 10 pages. People went over 7 minutes on the video, though. That's fine. If you're over 7 minutes, then I just put it on double speed. So you're safe up to about 14. Because what would you do with a video that was 14 minutes long and you didn't want to watch for more than 7 minutes? Yeah, 2x speed, right? At 2x speed, it's kind of like listening to Alvin and the Chipmunks kind of thing. 1.5 is a lot better. But some people's voices don't work at 1.5. Some people's voices don't work at 1.25. And don't everybody pick the first one on the list. See, what I should have done is just like split the class up and done it that way, but whatever. Too much work. All right, there we go. So let me go back and I will start from the middle. 3, 8, F3, B, C, 8, blah, blah, blah. Anybody pick that one? Third one on the list. Let me guess, everybody took the first one. You know, I'm perverse enough that, in fact, one of the things that I routinely do now is that when I'm putting together lists, I start in reverse alphabetical order. And do you know why? Because there is an alphabetical bias. And people whose names start with letters that are near the beginning of the alphabet, they don't even know that all of their lives they've been privileged to be called, or maybe they don't view it as a privilege, maybe burdened, all of their lives for being called upon first. And when you reverse it, you know who notices? The people whose names start with Z. Because they're not used to being called on early. And that's why I went to the middle. So no one paid attention to poor old 38F, 3BC, 89BF, 81FA, ECA, 30B69, D202, 64A, 43E. No one cared about it. So let's see then. Let's do the one above it. 205FOE1F4. I'm not going to keep doing that. Anybody look at that one? What'd you think?
I mean, it wasn't that good. Like, it didn't describe really too many details, I think.
Vague. Great. This is really good for you during a code review of this or design review of this is really easy because you got lots of stuff to pick on. What? I don't even know what you're building. Is this a Gutbuster 6000? And if you don't recognize that reference, it's the only season of the Dilbert cartoon, which is brilliant because the first thing they decide on is the name of the product. Not what it's going to do, but its name. And then that drives everything after that. So that's why, you know, it's like perfect. Remember, that's the most important part of your project is what you call the product that you're going to develop or produce. And then that will control everything after it. So, anybody else look at it? Okay, then let's go look at CEA 89408. And everyone else looked at the first one. Oh, a bunch of people looked at CE9? Okay, good. What'd you think? So what did I do? I picked the two from the middle first because I thought that what people will do is either go from the beginning or the end of the list and not from the middle. And if I'm really feeling perverse and I won't do it in alphabetical order, I will choose randomly. What'd you think?
I think the CCT was pretty good. Like, it's like referencing the test file. Go look at this test file, which is pretty good.
Great.
Test.
Okay, how about you?
Yeah, I thought the same for that, but then one of their tests, like they're trying to handle 500 concurrent incidents, but if there's an actual emergency on like a really large scale, you're gonna have way more than 500 incidents. So I don't know about how.
So their scaling might have been a little limited to, yeah, okay. Would that surprise you to see that in a student project though? There you go. So it wasn't unrealistic either. Good. Claude did an okay job. Yeah.
This one actually had field metrics. But, the other ones just mentioned that, like,
Oh, you looked at the others too.
I forget I said that. But this one has, like, specific details.
Forget what? I'm sorry. Did you say something?
I don't know what you're talking about.
Exactly.
Anyways, this one had like if what is it? Like if it reaches like 1,000 logins, it'll fail or something. Sorry, I'm skimming this game.
Interesting. Yeah, well, nobody read them all, so I can't really do that. Let's see. So, below average. So 113BA67. Did anybody look at that one? So that was given a below average rating. What do you think?
Yeah, I think like they don't really mention like specific like they say stuff like, oh, we validated this, we tested that, but like they don't mention any sort of metrics, and you just gotta kind of like trust them.
All tests pass. What tests? Comprehensive coverage. What percentage? Performance tests confirm acceptable response length. What does that mean? This sounds like performative BS to me. Is that about?
Yeah.
Okay, so the summary here is not too far off. Anybody disagree with this? Did they think this was like a really good piece of work? It was a piece of work, all right. How about 205F0E1, blah, blah, blah. Proxy share. Is that the one that nobody looked at? One of the two. What is another below example? Okay, so there you go. Now when you go back and look at them, you can see that. So, this is the one where you get the laundry list of technologies. Gee, I use Lambdas with Dynamo, DB, S3, CloudFront, Cognito, and SQS. What's CloudFront? Look it up. I'll wait. This one I think is worth looking up.
Yeah, I don't remember like the specifics, but it's one of the security ones. Like I can't remember off the top of my head what like.
Good guess. If you want to do this, take lessons from ChatGPT and just sound forceful. This is about security. I know that, and just make something up, and people will believe you. No.
CDN, which basically just allows hosting for like.
That's lovely. What's a CDN? He knows. This is the problem with cloud computing. It is filled with all of this terminology and all of these things, and you end up looking them up because you're like, I don't know what a CDN is. He just used the term. He knows what a CDN is because he knows that CloudFront is an example of a CDN. And yet, you probably have used a dozen CDNs today. Content Distribution Network, CDN. See, the real secret of the internet is that it's slow. It's like molasses on a cold winter day. It's like that experiment there. They're waiting for another drop of some sap from some flower to drop, and it only drops like once every 30 years. It's like the longest running scientific experiment, and they're all excited because it's about to drop again. I think they've got cameras on it this time. Last time it dropped was like 30 years ago, 35 years ago or something. It's crazy. It's like people, this is like a spectator sport, like watching paint dry or grass grow, except it's even slower. The internet is slow. And the way that we speed things up on the internet, including that experiment, which is now on a live feed camera, is we move the data that you might use so it's close to you. What does that mean? What is close to you? How do we measure distance on the internet? Anybody play like competitive online games? Anybody play non-competitive online games? Okay. Right, latency. And what controls latency?
Physical distance.
Well, actually, it isn't really physical distance. It is, in fact, but it's network distance. So latency is a measure of how long it takes for you to get something from where it's stored. A content distribution network is a mechanism by which we move copies of things that people are frequently accessing so it's closer to them, so that they can get that data. Why does that matter? I mean, it's, what is it? It's like, you got to go grab one thing from someplace. Look at the average web page now. The average web page can have hundreds of assets on it. And each of those assets has to be acquired from some location, some source. Have you ever gone to a website and noticed that it keeps rendering and keeps changing shape and keeps moving things around? It's because the content isn't uniformly available. So as it gets pieces of content for which it didn't have a predefined size, it has to readjust the page itself. The way that we make that less visible is by moving content closer to the consumer, closer to the user. A content distribution network is the mechanism by which this happens. And you pay for that when you build cloud applications because you want it to be fast. No one will stay on your website if it is slow. No one will use your app if 5 seconds have gone by and you still haven't shown them anything. What they're going to do is they're going to leave and go someplace else. It's called engagement. And it's a very important metric. No one, when's the last time you went to you pull up an app and it takes too long and you just go, oh, screw this, I'm going to go do something else. Uber Eats is too slow, I'm going to use DoorDash. DoorDash is too slow, I'm going to use Skip the Dishes. Skip the Dishes is too slow, I'm going to use Fantuan. Can't use Didi here. Not yet. You know, if you really want to live, you use like Rappi. I have the Rappi app too. And Didi. You haven't lived until, you know, the step down from like taking Uber is to take like a motorcycle. You literally sit on the back of somebody's motorcycle and they take you places. It's cool. Somebody builds apps that does that. That's a cloud example. It's a real world cloud example. And if my app to get you on that motorcycle is faster than her app, you're going to use mine. And since hers is clearly going to be superior to mine, I'm not going to have customers for very long. Of course, we know what's really going to happen is that everybody's going to use both of them and they're going to take whichever one is cheapest, right? So we need to negotiate with each other to share pricing. Pay no attention to the fact that that's illegal. You just have to work around those kinds of things. I wish I was making that up too. Right, so there's this huge long list. What is WireGuard? Anybody know? You might be using it. You never know. Go check. So you got a whole laundry list of these things, and none of this is made up. This is literally all technologies that you can use when you're building web apps. So as you're reviewing people's work and you don't recognize a term, go look it up. What is that thing? What is it used for? Why am I not using it? Why am I not the cool kid who's using DynamoDB with stun, turn, WebRTC, and ICE? I don't think that's the same ICE that's been in the news, but okay, so here we go. We've got an above average for crisis map, which has WebSocket server bottleneck at 200 connections, probably why they can't handle 500. And you know, some other issues. But then they talk about what they tried, what happened, what they learned. Guess what? For me, that's what I want to see. I tried something, it didn't work, this is what I learned. I tried something, it didn't work, I found something else, it didn't work as well as I wanted, but it worked better. Now I know what I'm looking for in the future. Now I know when I take 416 what I'm going to build, because their services are crappy and I'm going to build a better one. Whatever. They actually had real-world examples of what they had really done for tests. They had paths to their actual code, so you could go look at that. Am I going to go look at all that code? No, I'm not. But I'm going to sample it. I'm going to look at it. And when I'm looking at your capstone, if I'm left with questions, I'm going to reach out to you and I'm going to say, I need 15 minutes with you. And then I'm going to come with a list of questions. And I'm going to ask you those questions and listen to what you say. See, the weird part about it is that everybody knows this now, and they've known it for a while. The only effective way to guarantee when you're testing someone that they're not making it up, well, this is, I guarantee is too strong. The only way to at least have some reasonable assurance that they're not completely making it up is to do an oral exam. And this class is small enough I could actually do an oral exam for everybody here. Could be fun. Let's see. So the pattern here was they showed the work, they admit what it was broken, they named the trade-offs. That's why this isn't a complete success from a project perspective, but as far as I'm concerned, that would be a complete success from a learning perspective, because they learned to be honest. Here you go. CEA 89408, blah, 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 proxy share. Okay. So you can see how the project evolved. You can see what happened when they started dealing with NAT traversal. What is NAT? See, this is one of the things I think is weird. They don't require 317 for this class. And yet it's like the cloud is nothing but network. Right, network address translation. Firewalls. Actually, it's this general class of things called proxy servers. Network address translation is implemented by what's called a proxy server. NAT is the thing that you get an ISP. They give you a box. You put the little box there, and then everything in your network talks through that little box out to the rest of the internet. And that is doing what's called network address translation. So there's a single address that it shows to the rest of the universe, and then it takes all of the outbound connections from your devices, and it makes them look like they all came from this one box. And you can have up to 65,535 of them connections. Anybody know why it's limited to 65,535? It's another question for you to think about. So they talk about the NAT. They go into that. They talk about the empty chair. The empty chair is this concept of who am I screwing over that's not here? And literally almost everything you build, there's going to be someone who's potentially impacted by it who's not part of the decision process. And the point here isn't to say, oh, you're a terrible person for doing that. It's to say, here's a tool that you can use for thinking about who is being impacted by this that I'm not thinking about, that I'm not considering. How can what I'm building be used in a way that I don't anticipate? They had a cost analysis with some real numbers. They said that completing the project didn't mean they understood everything. And what's here is it's got depth to it. It shows reasoning. It's clear about the limits of the project. I'm sure it was all puffery anyway, but at least they were able to fake it sincerely. That was supposed to be a joke. I really need to get the Groucho Marx thing with him saying the most important thing in this business is sincerity, and once you can fake that, you've got it made. Because it's a brilliant line, absolutely brilliant. So the weak thing said they made assertions, tests pass, but I don't know how. So when you're giving people peer feedback and they pull this kind of thing, say, wait a minute, what tests? What does this mean? This is so meaningless, it doesn't tell me anything. You're putting all of the burden on me to go look at your tests. At least show me where to go look. I learned a lot. Okay, so what's the units for a lot? I mean, is it based in grams? Kilograms? Barrels? I learned 55 barrels worth of this. What? Okay. I don't know. I don't know what a lot is. So that's kind of useless. Discovered port restricted NAT fails 43% of the time instead of the expected 80%. Well, that's kind of interesting. Huh. At least it was specific. So maybe they made it up. But at least they did a good job of making it up. And then this is your opportunity to say, what does that mean? I don't even know what NAT means. The fat guy said it was, network address translation. Okay. You get the list of technologies, the laundry list. You can choose to do one deeply, or you could choose to explain, here are the three that I considered, and this is why I considered them, and this is the one I selected, and this is why I selected it. Because now there's actually at least some evidence that you gave it more thought than going, almighty 8-ball, should I use Postgres? Yes. Okay. Everything worked versus, some things failed. I mean, I have to tell you that when I'm sitting there doing an experiment, I get really suspicious when they all work. Ever done a scientific experiment of any sort or run a piece of test code? And if all the tests pass and all the code compiles the first time out, I'm like, really? There is something that just does not work here. No. That makes me suspicious. It's the opposite. Oh, everything was perfect. We had no problems, no bugs. Yeah, I don't believe you. Confident tone. This is probably too much time spent with ChatGPT, who will assure you that they are not lying to you. Or Grok. Grok is really good at this. How many of you have used Grok? Unhinged mode?
Oh no, I haven't used that.
Oh my god, that one goes way over the top. I mean, Grok by itself is pretty unhinged as it is, but yeah, it's funny. You just need to get it on one of those days where it's deciding to be a neo-Nazi, which seems to happen more often than it should, which would be never. You laugh. You've actually seen like some of the TikToks or read some of the, seen some of the videos about the weird shit that Grok has done.
When it posted that first one that went viral, like I saw the tweet like go out live, and then I was like, "There's no way they're gonna come back from this."
They did.
But it's still doing it.
Yeah. Well, this is one of those interesting things that LLMs turn out to be harder to get to do what you want them to do than you think. Of course, anybody who's spent 5 minutes with ChatGPT knows that, because you ask it for something and it will give you something that it thinks you need, not what you actually asked for. I'm being a little harsh on it, but yeah. They've been trying to tune it, right? And they try to tune it. Oh, we don't want this left-wing thing, and so instead they get neo-Nazi stuff. Okay, well.
Isn't that a huge problem with like Google's anti-gravity right now, where like Gemini's just not following instructions?
Gemini's turned into a piece of garbage lately.
It hallucinates too much.
It's just turned into garbage. It's pretty sad, because I've actually had I've had some very good sessions with Gemini. I've given up on it right now. And they'll fix it, and it'll be like almost as good as Claude, right? Claude has its moments though too. They all do. Okay, so here you go. Now you've got some calibration. You can go back and look at those things and say, oh yeah, okay, of course I would have rated it that way, to convince yourself that you're well calibrated. I mean, the better way to do this is not to look at the calibration tests before you read them, because you're biasing yourself that way. I'm going to talk briefly about this. So I think I have mentioned this before. This is going to be very briefly. Let's see. Flow Health is a case where these people built an app, and the app was used for tracking menstrual cycles for women, people who were trying to get pregnant. So they were keeping like sexual history there, their medical information, if they were trying to get pregnant, if they weren't trying to get pregnant, it doesn't matter. It didn't make any difference. And I was exposed to this case because I was interviewed as an expert for it. They went in a different direction, which is pretty common. And the thing that struck me was that what they did at the engineering level was just sloppy engineering. And if I had been doing the code review at that point, I would have been going, why are you sending labeled data to third-party providers? Not meaningless label. I'm a big fan of UUIDs because they really don't have any semantic information in them. No, instead, last menstrual cycle, last menstruation. You're like, what? Why would you send this to a third party? Better yet, why would you send it to Google and Facebook? What are they going to do with this? I mean, it's bad enough that people can figure out when women are pregnant before they know that they're pregnant. You do know this, right? At one point, like 10 years ago now, more than 10 years ago, very early machine learning, Target in the US figured out that they could determine when a woman was pregnant based upon what she was purchasing before she knew she was pregnant. They saw the patterns. I'm like, that's creepy. I don't know if I'm going to do the Cambridge Analytica talk this term. I did that last term, but if I don't do it, make me do it. Make me tell you. Cambridge Analytica built on top of a paper that Facebook did in 2013, where Facebook said, can we affect how people feel? And they took 600,000 people and they changed their feeds. And guess what the answer was? Oh yeah. Yeah, we can make people happy or sad depending on what we put in their feed. So they promised they'd never share the data. They sent the data out. They shared it. The engineering team was told, add more analytics. Don't spend any money on it. So they used free SDKs from Facebook, Google, Flurry, and Apps Flyer, and all sorts of really cool data, which they sent off and they got back. This was even for people who were paying for the app. So it wasn't like they were just doing this for the people who got the free version. Of course, when it leaked, the company blamed the engineering team. Now, I will tell you that the legal process basically said, no, that doesn't work. So the C-suite, they definitely took it in the shorts. But it didn't work. But it didn't mean that they didn't throw them under the bus either. And that's why I warn you, make sure you protect yourself. That's why it's important to document these things. In the US, that case is in wind down. I still get notifications that there's constant updates to the case. The case was decided last summer. Canada has a case that just started a couple of years ago. These things take 5 years, basically. And that is here in BC, and it's called Lamb versus Flow Health. So the lesson to you, make sure that if you mention, like, hey, shouldn't we be testing to make sure that we're following our terms of service, and the engineering manager says, no, don't do that, document it and store it. Don't make a big deal of it. You're a junior person. Don't lose your job over it. Just document it so that when they come for you later, oh, I told them we needed to do that. They said no. Protect yourself. There you go. And you can actually build CCTs for this stuff. There we go. You're going to have peer reviews to do. What you're going to do is you're going to pick, you're going to go through somebody else's repo, look at their design, give them critique or feedback on it. That's what's going to happen soon. There we go. Done. 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 And that, I don't think that one works either because it's just the same one. Okay. Right. That's not right. I still missed one. All right. Next week we will talk about data storage and life cycles. It's an upside down A. Well, because it's almost like the mathematical symbol, but I'm not sure what I'm supposed to mean with its upside down A. Or maybe you're just drunk and I'm drunk and I don't know it.
On the item description, it actually says a V. Although the official brand is an A.
An upside down A. Okay, interesting. Oh, so you're just a walking billboard for the product. I got it. Okay, cool. I understand now. Let me stop the recording so people won't have to listen to me ramble. Not that anybody. Does anybody watch these videos?